If you hold a ball and let go, gravity dictates exactly where it goes. This is a deterministic experiment, predictable through physical laws. Rolling a die is different. It is a random experiment. We know every possible outcome but cannot predict a single roll. Because we cannot predict these results through physics, we use mathematics to measure the likelihood of each outcome. This is the study of probability. Outcomes are categorized using sets: natural numbers, integers, and real numbers. Within these, we define subsets. If subset A contains even numbers on a die, rolling a 3 puts that result outside the group. We denote this as 3 is not an element of A. Identifying what is excluded from a group provides the formal definition needed for set-based calculations. We use Venn diagrams to visualize how subsets interact. Circles A and B represent two conditions. The intersection represents outcomes satisfying both. The union includes outcomes satisfying A, B, or both. The difference isolates A by removing B. The complement identifies everything outside of A. These four operations allow us to isolate the specific events we need to measure. We manage operations using the KADM rules. K and A represent commutative and associative laws, showing that set order and identical operations don't change the result. The D stands for the distributive law, allowing us to expand an operation through a bracket. The final rule is named for Augustus de Morgan. His law describes the relationship between unions, intersections, and their complements. Try to visualize this. Draw two overlapping circles and shade the complement of the union of A and B, the area outside both circles. This shaded area is the geometric representation of De Morgan's law. It shows that the complement of a union is mathematically identical to the intersection of the individual complements. Set theory defines the shapes of these events, but we need numerical values to calculate probability. Andrei Kolmogorov formalized the three axioms used to assign these values. The first axiom is positivity. Probability must be 0 or greater. Second is normalization. The probability of all outcomes combined must equal exactly 1. Third is additivity. If two sets have no overlap, their combined probability is the sum of their individual probabilities. These three axioms define the mathematical constraints for the calculations that follow. We assign numbers in three ways. Classical Laplace probability divides favorable by total outcomes when results are equally likely. Objective probability relies on historical long-run frequencies. Subjective probability relies on expert assessment and Bayesian updates when data is unavailable. By combining these physical experiments with the structural logic of sets and the boundaries of the axioms, we have a complete framework for measuring chance.